HRE's goal is to be the industry leader in innovation, and using additive technologies is one of the many ways we intend to revolutionize how wheels are made.
The reaction of the first HRE3D Plus wheel was actually really insane. I think it really shocked people, and they weren't expecting something like that from us. So it made us really happy that people responded so well to it.
So for us, with this project, we wanted to see how far we could go and push the technology to fully understand how far away we were from being able to bring a wheel to market.
When I think about the project that we're doing with HRE, I think, one of the beauties of working together, I think, as a team is HRE's taught us a lot about what's important in custom wheel manufacturing and custom wheel design. So when we talk to them about, hey, go think about designing your wheels differently, they immediately jump to, oh, okay, cool, we can go design something different.
I think HRE's culture really lends itself to this project. We're a small company. We're always looking for the next best thing. Doing this project with GE really fit our culture and how we think about approaching projects.
Obviously, GE is a much larger corporation than HRE, but when working with the AdWorks team, we almost feel like we're working with a special part of GE. Their flexibility, their commitment, their passion was frankly unexpected, given we're working with one of the largest corporations in the world.
The intersection is where the magic happens of, how do we help their problem or their challenge and open new design space for them that they probably have never been able to explore.
GE has two major additive technologies. One, the electron beam EBM process, and the second, laser DMLM process.
The EBM process is a powder bed additive manufacturing process using an electron gun as the heat source. Typically it's either 3,000 or 6,000 watts in a vacuum environment, and we're selectively melting layer by layer the metal powder into a solid part. DMLM is a laser powder bed fusion process. You've essentially got powdered metal. You're melting a 2D cross-section of a part. It's a very high power laser, typically 1,000 watts, focused very finely. You're selectively melting that powder into a solid part layer after layer.
So one area where we've been working urgently with Geonics is we've worked on a software we call Verfac that provides what we call build compensations so that we know when we print it, it will match the design intent.
With the first wheel, we were locked into having 6 pieces to make the wheel hub all bolt together onto the vehicle. We were able to refine that into having 5 sections that interlace together so that the actual design was part of the fixture to the vehicle. We got to interlace the parts together, but then take the cap bar and raise it up out of the hub area to hold the cap, almost like it was holding it proud from the wheel. But we definitely redefined the interlacing structure between the P201 section and P101 section. And we found that using a trapezoid section through the connective tissues from top to bottom really helped to keep the wheel a lot stronger. So the ellipse that we used on the side of the P101 section was used so that we were never going over the 45 degrees and were able to window through the spokes and have an interlacing structure.
When we think about technology development at GE Additive, one of the areas that we focus on is really the customer's outcome.
We've done these 2 projects, we've been through multiple technologies. I think it's only a matter of time before we find that final answer of which additive technology is going to work the best for us.
So what we've learned going through these projects is that while additive technology still is a little bit in its infancy, the opportunities are tremendous. And while the idea that anything is possible may not quite be realistic yet, we know that's coming. And we know that additive is going to change the world. And I want to make sure that HRE is a part of that.